A curve has this equation. Find an exact equation of the tangent of the curve at the point on the curve where x equals pi over 4. The region shaded on the diagram below is bounded by the curve y equals 4x cos 2x and the x-axis from x equals 0 to x equals pi over 4. By using integration by parts, find the exact value of the area of the shaded region. Okay, that's the question, and I've got it summarized here. So, the tangent, so we need dy dx, it's product, so we'll use the product rule. One of the constituents is itself a function of a function, cos of something. So let's have a look at that then. So let's get dy dx then. U times dv dx, this differentiates cos of something goes to minus sine of something, multiplied by the something differentiated, which is 2. So that's u dv dx plus v cos 2x times du dx, which is 4. Okay, so at pi over 4 then, 4 times pi over 4 will be just pi times 2 times minus sine. 2 pi over 4 is pi over 2 plus cos pi over 2. 2 pi over 4 is pi over 2 times the 4. Cos 90 is 0. Sine 90 is 1. So sine pi over 2 is 1. So we end up with minus 2 pi when x equals pi over 4. So, we also need the y coordinate, don't we? So y at x equals pi over 4 then. Y is equal to 4x cos 2x, isn't it? 4x cosine 2x, which would be pi over 2. 4x is pi over 4. Cos pi over 2 is 0, so this is 0. So, tangent then, y minus the y coordinates is equal to the gradient. The gradient of the tangent is minus 2 pi times x minus the x coordinate, which is the value pi over 4 on the curve. Okay, so y is equal to then minus 2 pi x plus 2 pi times pi over 4 will be pi squared over 2. So that tells us the equation of the tangent is 2 pi x, move this over, plus y plus pi squared over 2 equals 0. And this should be a minus when we move it over, shouldn't it? We left the y as is, we brought that over with it and made it a plus, wrote it first, move this over and make it a minus. And that's the equation of the tangent then. Exactly. So that's that. Find the shaded area. It said use parts in the question, didn't it? So b between 0 and pi over 4. So the area is equal to the integral between 0 and pi over 4 integral y dx, which is 4x cosine 2x dx. Let's just remind ourselves that we've got the function written down correctly. 4x cos 2x here, so that's fine. Okay, so we need to do parts. So if we label this v and this du, then we can write down the answer, can't we? So it's going to be u, which is sine, integral of cos is sine, and we need a 2 underneath, don't we? So that's u times v, uv, there we go, between 0 and the pi over 4. That's the uv minus the integral of u, which is this, times the v dx, and that differentiates to 4, so I'll put the 4 here, dx. So this just cancels down to 2 between 0 and pi over 4. So that's equal to then, let's work out this value, pi over 4 in here, we get half sine pi over 2 times 4 pi over 4, which is pi. That's the top value. Take away the bottom value when you put naught in here. Sine naught is naught. So it doesn't matter what the other term is. This will work out to a product of 0 minus. Now this is the integral of 2 sine 2x. So the integral of sine is cos minus cos, isn't it? Cos goes to minus sine, so we put a plus here. We'll need, the 2 comes, when we differentiate this, the 2 will come out to be the 2 that's already there. So it's fine as is, isn't it? It's just plus cos 2x. This term differentiates to the 2 sine 2x, doesn't it? And that's between 0 and pi over 4. Now, okay, let's see what we've got then. Sine pi over 2 is 1, so this is pi over 2 here. Okay, cos 2 pi over 2 will be 0. So the top value will be 0. Take away bottom value, put 0 in, you get 1. So it's pi over 2 minus 1. It's a measure of area, so it's units squared. That's the solution to the integration by parts.